Good morning to all. I am Professor Navneet Kaur from Department of Electronics and Communication from Sagar Institute of Research and Technology College. In this session, I'll be discussing lab practical of Digital Signal Processing EC601. Here, there is a list of experiments in which I have given 10 experiments. Today, I will discuss fourth practical, which is write a MATLAB program to compute and plot linear convolution of two signals. The software which I will be using in this experiment is the MATLAB software. First, I will discuss the theory of the practical. If I want to find out linear convolution of two signals Fn and Gn, the linear convolution is given by the formula summation k is equal to minus infinity to infinity fk gn minus k. The linear convolution is used to find out the output of any LTI system in which any arbitrary input is given to the system and the unit impulse response is known to us. The linear convolution is commutative in nature, that is, linear convolution of f with g is same as linear convolution of g with f. So, in the formula of linear convolution, if I will write summation k is equal to minus infinity to infinity fn minus k gk, it will be same as equation 1, which is summation fk gn minus k. Now, first we will take the MATLAB code. Now, I want to find out the linear convolution of two sequences. So, first I will enter the first sequence. For entering the sequence, the MATLAB command used is input. X is equal to input, enter the sequence. That means X represents the sequence. So, when I will enter this command, the MATLAB command window will ask for the sequence. So, I will enter the sequence is some square bracket 1 2 3 4 5. Now I will find out the length of this sequence, which is given by the command capital N is equal to length of x. Now there are n number of samples in sequence X. So if I want to plot this sequence, I will take the time parameter which will be plotted along x-axis n. It will be given by 0 is to 1 is to n minus 1. That means the n value of n will start from 0 and it will go up to n minus 1 with an interval of 1. Now I want to draw this graph on first position, so I will divide the figure window into 2 rows and 2 columns. For that I will use the command subplot 2 comma 2 comma 1 because I want my graph on the first position. Now since I want to draw the discrete time signal, I will use stem command stem n comma x. Now for labeling the x-axis and y-axis, I will use x label and y label, x label n, y label xn, and the title I will give first sequence. Now I want to enter the second sequence. Now for that I will use the command input. So h is equal to input, enter second sequence. Now it will ask me the second sequence, so I'll enter the samples 6, 7, 8, 9, 10. Now if I want to plot this sequence, I will first find out the number of the samples in the sequence, which is given by n2, which is written as length of h. Now since there are n2 number of samples in this sequence, so I will take the parameter of time n along x-axis. Small n will be given from 0 to n2 minus 1 with an interval of 1. Now I'll draw this sequence on the second position. So subplot 2 comma 2 comma 2, and the command which will be used for plotting will be stem n comma h. Now for labeling x and y axis, x label n and y label hn. The title given will be second sequence. Now I already know the two sequences xn and hn. Now I will find out the linear convolution which will be represented by y. Now for finding the linear convolution, the command used is conv bracket x comma h. These are the two sequences of which I want to find out the linear convolution. Now we already know that the number of the samples in the linear convolution sequences n1 plus n2 minus 1, where n1 is the number of samples in first sequence and n2 is the number of the samples in second sequence. Now here the number of samples in sequence y will be n plus n2 minus 1. So if I want to plot it, I will define the parameter of time n, which will start from 0 and will end at n plus n2 minus 2. So total number of samples will be now n plus n2 minus 1. So n will go from 0 to n plus n2 minus 2 with an interval of 1. Now I will draw this graph on the third position. So the command used will be subplot 2 comma 2 comma 3 stem n comma y. For labeling x-axis and y-axis, x label n and y label yn. Now I'll give the title. Title will be convolution of two sequences. When I will run this MATLAB program, the graphs will be, this will be the first sequence, which is xn. Here we can see the samples are 1, 2, 3, 4, 5. Now this is the second sequence, which is hn. Here also the number of samples are discrete in nature, n and hn. So here I can see 6, 7, 8, 9, 10. When I have convolved the two sequences, the result of linear convolution is represented by yn, and we can see here the number of samples will vary from 0 to n plus n2 minus 2. So this will be the resulting linear convolution of the two sequences. This is all for today's session. Thank you.